the combination of metasurfaces with algorithms makes this an extremely powerful paradigm, because I think, as a general emergent theme in a lot of electrical engineering and computer science concepts, it's really the ability to tailor the optical response of metasurfaces for together with algorithms to do a specific task more efficiently or faster. That really is starting to showcase, where there are decisive advantages. So I think that's extremely exciting as well.
Our fundamental work that's on the cutting edge of metasurfaces. I'll point to maybe three areas that I think are really exciting. One of which you mentioned, inverse design, thinking through what particular optical transformation or spectral response you want and how you can get that with the design that oftentimes may not be what you intuitively predict. I think that's a really exciting opportunity. I think another exciting opportunity for metasurfaces is thinking through nonlinear phenomena, especially since we're in a regime now where metasurfaces can enable, strong light matter interactions. We can move to a point where we can start to enable some of these photon-photon interactions or nonlinear behaviors that previously have been really challenging to access at the nanoscale. And there's a variety of approaches for achieving, say, nonlinearity or non-reciprocity, but I think we're just on the cusp of a breakthrough for how to enable efficient nonlinearities, which I think will be key for a number of future technologies. Kind of a third fundamental area that we heard a bit about at the workshop and that I think is really exciting is using metasurfaces for quantum information and how we can interface metasurfaces with quantum materials, whether that's, defects in nanoparticles, defects in solids, or in two-dimensional materials, and use the strong light matter interactions of metasurfaces to be able to control either an optically addressable spin qubit, including its, brightness, its polarization, and its coherence. So I think we're going to see a lot of really exciting breakthroughs in the future for metasurfaces applied to quantum information sciences.
Applied materials is very much, with its long history in creating new materials, making thin layers and structuring thin layers for the semiconductor industry, wants to use those abilities to also do the same for optical metasurfaces. One example is AR, where going from the display, you need diffractive optical elements to make a waveguide expander and image or make a projection image of the display on your glasses. This is one example of metasurface-based optics, and there are many more opportunities.